Alrighty. Good evening, everybody. Welcome back to Coding Together. Advent of Code, Day 4. My name is Savani. I am a software developer with 25 years of professional experience, and the purpose of this series is just so you, the viewer, can see just how much even a professional with a lot of experience can struggle when writing code on just doing the day-to-day work. We are working through the challenges for Advent of Code, a series of 50 coding challenges, 2 per day, that start on December 1st of every year. They're just little challenges where they give you a description of the problem, they give you an input data set, and you just reply with a single number, usually. We've done days 1, 2, and 3 on stream, and before we even start on day 4, tonight, I am going to revisit day 3 because there was something I was working on just before I signed off that I was able to figure out this morning after I'd had some time to sleep on it and look up some documentation. So, apparently I didn't, somewhere around here I've got a browser open. There we go. Bring that over. Advent of Code 2024. Do some zooming in just so everybody can see what's happening. 5. Okay. So yesterday's problem had to do with parsing or scanning through this data set, finding operations. For this first data set, it was just finding these multiplication operations, calculating them, adding them together, and returning the value. Part 2 got more complicated in that I needed to detect both the multiplication and the don't and do statements. And on stream, I solved it with a regular expression that had 3 parts. That's basically the upper limit of a regular expression and what it can do without just becoming unreadable. And even then, it was already getting to be unreadable. So I tried switching over to NOM parsers. NOM is a really robust library for doing data stream parsing in Rust. And because I hadn't written a parser in 6 months, something very basic just went right past my mind. That very basic thing is, you'll note here that the first operation that we're going to detect is not the first character. Need to throw away data. And it's this thing where I have to check each character and throw it away if it doesn't begin a parser. And then even if it does begin a parser, if it fails to fully parse, got to throw all of that away too. The solution was very simple, and I'm going to show it to you right now. So we're going to go into the Advent of Code repository here. Day3.rs. Here we go. Okay. So an overview of the parser. Actually, weirdly enough, NOM parsers are easiest to understand if you start at the bottom and work your way up, or at least I find them so. So I'm going to do exactly that. I'm going to start out at the bottom, which is the 3 parsers that match the operations that we want. Do and don't are both easy. If the next set of data in your data stream is do followed by open and close parenthesis, great, this parser matches. Return the operation do. Same with the operation don't. Multiplication is more complicated. Need to match the MUL open parenthesis, then extract and interpret 2 numbers separated by a comma, and then match the close parenthesis. And if any of those fail, it's just an invalid operation. But if it all succeeds, return an operation. We want to then combine it all together. Match operation here, which is a parser which will check in sequence each one of these 3 parsers on the data stream. And it's like the way it would work under the covers is it would check the first character against the first parser. If that passes, check the second character, and so on and so forth. As soon as it fails, jump all the way back to the first character and start doing the same thing on the next parser. And it's only if all three of them fail that this operation fails. So far, so good. The final step, and the one that I knew had to be easy, but it just wasn't occurring to me last night, is how to discard the leading data. And the solution for that is this parser, Manytil. What you give it is two separate parsers. One of them is data that you want to match, and the next one is a parser that is, this is where you're going to stop matching data. So Manytil is going to, in this case, take any character up to the point where this operation finally succeeds, i.e., it will take any character until it detects a do, a don't, or a molt. And what it returns then is the result of everything it collected with this first parser, followed by the result that it collected with this last parser, which I end up just discarding everything that it collected with this first parser. That's how I discard all of the data. And then the final step is to just apply that next operation through the entire data set. Don't even have to detect an EOF. In fact, you only have to detect end of file if you actually really strictly care about end of file. In this case, it's just going to run out of data eventually and return everything that it got. And I wrote all of this, got it working, proceeded to apply it against the real data set with the final answer, and it just worked. And in fact, it worked almost, at least to my eyes, instantly, although I was talking to the guy I know who writes a lot of nom parsers, and he said that this operation, what I'm trying to do here, is actually greatly inefficient. It's like a quadratic time complexity. And that's because it's actually going to run this parser against every single character, just running down the list, and then it'll run this parser. And so it's like running multiple parsers on every single character. And so that's why it ends up being very inefficient. But in any case, that is the first of the successful nom parsers in this advent of code. We're going to put that one away now, I believe. Yep. Let's commit this. So we're going to switch day 3b to a nom parser and push that up. Whoops. Keep all of my SSH keys and whatnot in one password, so I need to open that up right quick. There we go. Okay, let's start on day 4. Normal ritual of doing the setup here. This time I'm gonna, no, that's a bad idea. Let's not do that. Vim source day4.rs. Gonna open up main.rs. Maybe one day I will find like a faster and more efficient way of doing this. I don't really know what that's going to look like, but it would be cool. Okay, save the file. That'll get this portion compiling just fine. Day3.rs. Gonna import that. Okay, now that we've got that, we're going to go ahead and populate the data file. So, data day4.txt. And who knows, maybe the next time I stream, I will do all of this startup ritual before I go on stream so that you all don't have to watch it. Alrighty. So, day 4. Looks like the chief's not here. Next. One of the historians pulls out a device and pushes the only button that's on it. After a brief flash, you recognize the interior of the Ceres monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you can help her with her word search, which is our puzzle input. She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance of Xmas, you need to find all of them. So this really is just going to be a grid problem. And I think for once, I am not going to write my own grid library. Yep, I am not. Let's go to crates.io and go searching. The same guy who talks about non-parsers all the time talks about other things that he makes, and unlike me, that's not it. Unlike me, he actually finishes and gets them posted somewhere. Is this it? No. I mean, that might work, but I'm looking for... I wonder if I can search by name. No. Well, that's a bummer. Maybe I'll write my own grid library again and have it ready for next year. Yep, let's do it. Let's do it, just for the fun of it. Okay. Generally, the way I implement this, even though I'm working with two-dimensional data, I implement it as a one-dimensional vector. You could implement it as a two-dimensional vector, like a vector which contains a vector of characters, but I'm just going to do it one-dimensional. I have this superstition that it's faster, and maybe it will be, but I also do quite a lot of work with hardware, which even when you're thinking about two-dimensional, it mostly gets represented as like a one-dimensional memory array, so you have to actually still work with it. Basically we just start out with the data, which is going to be not going to be a string, it's going to be a vec of, we'll say car, make it simple. We're going to say width is going to be a U size, height is a U size, and we'll start out by writing the parser. And the parser today is going to be very simple. Just take this entire block, split it into lines, then for each line split it into individual characters. So let's see here. Impl from string for grid. Fn from input string return self. Ooh, I hit page down. We're going to say width, height, and data. So starting out, I'm going to do it. Okay. If we imagine that this, or if we're starting out with a vector that's like this, I'm going to squish it into a vector that looks like this. So it'll be the first row, followed by the second row, followed by the third row, and so forth. Come to think of it, I'm not even sure I need to split the lines. I possibly just need to... Huh. This should be fun and a bit more efficient. So input.intoIter dot filter. I'm just going to filter out end of line. C is not equal to end of line. Is this going to be the character I want, the type I want? Maybe. Maybe it should be as cars. Yes, that iterator. Cool. And so this is a character. If it's not, we accept it if it's not equal to a new line, and then collect it as a vec of U8. However, I have made a mistake in that I have not calculated the width and the height, then I'm going to need both of them. Oh. That's a mistake. Okay, and dereference this. Cool, so that's good so far. So the width, I assume that every row is going to be exactly the same width. So first I'll figure out the height, which is just going to be let height equals input dot lines, which I believe is an iterator. Yes, it returns an iterator. And then dot count. Start that way. And now let first row equals input dot lines dot next. And I know that there has to be a first row, so I'm going to unwrap it. Okay, and then let width equals first row dot len. I think that's it. I'm going to verify that that's the case here. So we'll go ahead and write a test. It parses the grid. Do-do-do. So I believe that the grid width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that the grid height 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is also 10. And then we assert EQ. I'm not going to bother asserting the grid data. Get all the types to match up there. There we go. And we haven't run any of the tests yet, so it's time to get that started. Okay. Where is the test I care about? Day 3, day 4. Here we go. It parses the grid. Perfect. First success. So now we have to get elements from the grid. So I'm I'll just call it elem. I'm going to refer to the coordinates as x and y, pretty standard there. And then this is the part that it's confusing enough that I can never memorize it. I have to actually work it out every single time I solve this problem. X is the distance across, y is the distance down. So when y is 0, there's nothing complicated. We just look at self.data x, and that gives us the distance across here. But when y is 1 or higher, we have to jump forward the number of elements in the row. So if y is 1, then the very first thing we do is we multiply that 1 by the width of the grid in order to jump over the first, in this case, 10 elements, and then we add x. And this is not a valid method in this particular trait implementation. There we go. And then let's assert that we're correct here. Something interesting, I guess. Going to be hard to do given that almost all of the characters are X, A, M, or S. I guess what I can do is check the last character of each one. So grid.elem X is 9, not 10. 9, 0, because everything is 0 based. Three, 4. That should be enough, doing 4 of them. 1, 2, 3. So A, M, X. Let's verify all of that. Sweet. Okay. Of course, this is going to crash if you go outside of the bounds. If you exceed the width, in fact, I think I'm going to go ahead and panic if you try to pull up an invalid address overall. So if y is greater than or equal to self.width, no, self.height, or x is greater than equal to self.width, panic, out of range. And let me make sure, because I frequently get it wrong, let me make sure that I can get the last one, which should be 9, 9. Awesome. It does still work. Cool. Okay. Going back to the problem itself, now that I have a grid to work with, if I have the data set, Xmas occurs a total of 18 times. So that's the first thing that we want to solve. Return 0 and make sure to pass a reference because we're not going to consume the grid, and this should fail with a 0. It does. Good. Okay, so the way I'm going to do this is probably the most naive way imaginable, but I'm going to find every instance of the letter X, and from that one, I'm going to traverse in all 8 directions as far as I can. And if I find Xmas, then it counts. I feel like that's going to be a lot of tedium. And the way I'm going to do it is I'm just going to start at 0, 0 and walk my way across. So for X in 0 dot dot grid dot width, once again, I've hit the page down button. For Y in 0 dot dot grid dot height, check Xmas at grid X, Y. And let's have the accumulator. So ACCUM equals 0. That's what we're going to return. Let's call it ACC. If check Xmas, ACC plus equal 1. Okay, the test should still be failing. Because I should still have a 0. I did not make that mutable. Should still be getting a 0 back from find Xmas. And I am. Good. At 30 minutes and my cup of tea has had some time to cool down. There's probably some optimizations that I can run, but how do I want to do this? Like, it's kind of a state machine. I want to check 4 letters. I want to do it in sequence, but that sequence has to be by direction. Okay. Let's declare directions. So there's right, down right. Actually, let's do it by compass points. So east, southeast, south, southwest, west, northwest, north, and northeast. I don't know how to iterate over that, so I'm not going to. I'm going to do this kind of a clumsy way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so match direction. Copy and paste. Oh, wait. I'm not too far off from it, but what I actually want to do is have a move pointer function. So we give it an address. And we give it the direction and we return a usize. And in fact, I'm going to make it a little bit more sophisticated by making it an option and giving it, I'm going to give it the grid, but we're not really going to be traversing the grid. We're just going to have that in order to know whether, or in order to be able to detect when we're hitting the boundaries of the grid. We don't want to go outside of the grid. And then if we really wanted to, that would give us some optimization where, like, if we know that in a specific direction we are not far enough away from the edge of the grid to find any 4 characters, then we could just bail early. But I don't think I'm going to implement that optimization because I think that this is going to run just plenty fast enough. So if we want to travel east and we're moving the pointer, if let's see here, if grid.x is if x is less than grid.width, grid.width is going to be 10. If it's 9, it's going to be grid.width minus 1 actually. Then we're going to say sum x plus 1 sum y plus 1. No, sorry, sum y, or no, x plus 1 y. And we can actually make this a guard instead, a guard expression instead of a full-on if, which is going to be a little nice to have in a few minutes. Well, it's going to be nice to have right now, where we just return none if none of the guard expressions match. So this should give us a rightward motion. It's going to be southeast if x is less than grid.width minus 1 and y is less than grid.height minus 1. We'll do that. If south, then it's basically just going to be that copy and paste may not be as obvious as it should be. I probably should have just retyped it. But so far so good. I think we're doing okay here. For this one, I am going to copy and paste because all I have to do is change the signs of the calculations. So if we're going southwest, we still want to be checking y against the grid height, but x we're actually going to check against 0. So if x is greater than 0, it's going to be x minus 1, y plus 1. And probably the type checker is going to get angry with me because we're talking about usizes and I'm subtracting, so I might have to come back and do a coercion. If going west, then we only care about x. Y remains the same. If, what's the next one? What's the next one? Northwest. If x is greater than 0 and y is greater than 0, we're going to return sum x minus 1, y minus 1. If going north, then we only care about y. Okay. Don't quite have it. I've got brace problems. Looks like it's because I failed that. Oh Lord. Yeah, okay, I need tuple syntax. We're going to do some very tedious insertions in here. I'm not quite good enough with Vim regular expressions to be able to just do that as a regex. Okay. Expected bool. Okay, yeah, that makes sense. So this is a case, though, where there could be any number of bugs hiding in here. So if I run into problems, especially with the test data, I'm going to have to write tests against all of this. It's not going to be fun. But I'm going to hope that I got it right this time. Actually, before I write tests, I may just like try to proofread it all. But I'm going to hope that I got it right. Now, we have a way to move the pointer. We have a starting point, and we have a direction. So each time we want to do 4 steps. So yeah, what we'll do, actually, instead of 4 steps, we're going to just match against the letters. So for car in Xmas dot cars, and that's a keyword, so I can't use that. We'll use C for C in Xmas dot cars. We want to check against the current one. Well, that'll be easy. Grid.lm xy equals C. So if it equals, then we want to continue on. If it doesn't equal, we want to return false. Just bail. We're done. If everything passes, we're going to return true. Okay. So here's the trick, and it's the order of when to move the pointer. We're going to check the current one, and if it matches, then we want to move the pointer so that we can check the next one. The thing is, the last match, we don't necessarily want to move the pointer again. It might not matter. I want to do let adder equals so we have the current address that we care about. We're going to move it. So this is mutable. So let's see here. If for C and Xmas.cars, if let sum cx cy equals adder. Actually, I'm going to try something. I'm not sure if the syntax is valid in Rust. So if cxcy is adder and grid.lmcxcy equals C, then we move pointer cxcy. And that really means let adder equals this. Give it the grid. give it the direction. Now the question is, do Cx and Cy exist in time for this to be valid? It's hard to tell. Let expressions in this position are unstable, and I'm not running an unstable version of Rust, so we'll just nest the if again. Okay, and Xmas needs to be that. And the direction, why can I not? Oh, direction is getting moved. I need to copy it. Copy, clone, whatever. What have we got? I found 800 instances. 800. It's a very round number. I kind of get the feeling that literally everything passed. Also, I'm giving it the wrong input string anyway. So, yeah, okay, that's no good. Oh, because I'm hitting... Yeah, okay, I'm doing the if this exists, else return. That's not right. What is the real condition? If it's sum, I'm going to return false. Well, here I want to return false also. So if this is not sum, oh, it passed. Okay. Okay, so the part that I was about to brainstorm through turned out to be true. So the first condition here, if the address is none, then while doing these checks, we've hit the edge of the wall. I'm thinking of an edge case that I'm going to need to check. So we've hit the edge of the wall. We want to bail. If the address exists and the character mismatches, then this is not an Xmas, so we return false. If everything passes for all 4 characters, we're going to return true. Now, here's the thought, though. We get S. We find the character S at the very edge. We do the if let sum. We're still in a valid address. We're matching S against the very edge, like the rightmost. It does match, so we move the pointer. So address is now none, but we don't have any more characters to check, so we are not even going to come back in and notice that address is none. We're going to go ahead and return. So I think we have the first solution. So take a look at the Elf's Little Word Search. How many times does Xmas appear in this data set? Like, this is madness. But that's okay. That's why we have computers solve these things. Yep, okay. Format grid dot, no. Find Xmas grid. Looks like Xmas appears 2,633 times. I also want you to note, actually, you know, even for good measure, we'll just run it. Yeah, even on that big data set, doing this like super naive way, it calculates this out in like 0.2 of a second. And that's wall clock time. Like actual calculating system time is about 30 milliseconds, it looks like. But let's see if it's the right answer, because who cares how fast it is if the answer is wrong? It is the right answer. Awesome. Continuing on to part 2. Okay. Oh, apparently I misunderstood the assignment. Okay, so looking for the instructions, you flip over the word search to find out that this isn't actually an Xmas puzzle, it's an X-mass puzzle, in which you're supposed to find 2 mass in the shape of an X. One way to achieve that is MAS. Oh, wow. Oh, that's kind of fascinating. Okay, so the same example from above. Okay, so we get to eliminate a whole bunch of the directions, and we're only looking for 3 letters. So if I could start from the center of each one and do the check that way, I think the part that's a little confusing, I'm going to assume... Oh, that's kind of fascinating. My music stopped a while ago, and... Oh, okay. Yeah, my music stopped a while ago, and then my phone interacting with my headphones caused the music player to start up again. I guess I don't need to go start new music. Okay. We've got an MAS. Okay, so the mass, the MAS, can occur in any orientation. I think what I want to do, and I get to keep my move function for this, but I think I want to start in the center of each one. And then check the 4 corners. And it looks like north, south, east, and west don't matter. It's just going to be northeast, southwest, and so forth. Okay. Interesting. Probably not as difficult as I'm feeling at the moment, though. So we're going to create a new function, fn check x mass grid size y u size. Direction doesn't matter in this case. Okay. I'm going to go ahead and do an optimization here where I'm just going to skip over the first row, the first column, the last column, and the last row. Like, we know that that can't be the center of anything. We also know that we're looking for an A wherever we're starting. So for x in 1 dot grid dot width -1, for y in 1 dot grid dot width -1. If grid dot lm xy is equal to a, then we have a maybe this is going to be a thing, and if not, we're just going to skip on. Yeah, okay, hang on. I'm right. I'm naming my functions incorrectly. This is the find function. And I'll actually write an fn check xmas right here. And it's this function right here that's going to be the one that does the real checking, whereas this is just going to iterate over the whole grid. I'm going to move everything down a bit. There we go. Okay. So find xmas, let mut acc equals 0. We're going to return acc, and then if check xmas grid at xy. This is wrong. Then we want to acc plus equal 1. Grid, wrong check function. There we go. Just going to always return false here. And now I want to write my test. And the correct number in this case is 9. Okay, the test is running. We're using the new function. Awesome. Now we come back here. So we know x and y. We're going to go ahead and check the center. Like, that's the easy one. If grid, actually we'll say if not grid.lm xy equal a, because we know that the a has to be at the center. We're going to return false at this point. Just bail out early. So now if we've got an a, we need to find an m in one of the 4 corners and an s in the opposite corner from where we find an m. And then we need to check the remaining 2 corners. How do I want to do that? I'm going to extract all 4 of them. So, let LR equals move pointer, grid dot, move pointer grid xy. We'll start out by going northwest. Now if that succeeds, then I want to get a value. So we've got an option usize, so cx, cy. Yeah, okay. Grid.lm cx, cy. And that should give me an option of LR. And then, actually, northeast. I just did northwest. So northwest, so up and to the left. Northeast, up and to the right. Southeast. Which is down and to the right. And then southwest. So we've got all 4 of those. All 4 of them are options. Cannot apply unary operator type car. Oh. Do the compare. There we go. That should do it. And I'm going to return true here. It's going to give me the wrong answer. And that's okay, given what I'm doing at the moment. Perfect. Okay. Code compiles, it runs, it gives me too many. That makes sense because I'm only checking for I'm really just counting the number of A's here. So next check. How do I want to do this now? If let sum no, wait. Match NW, NE, SE, SW. The default will just be to return false because for some reason I've hit the edge. Now, bear in mind, I shouldn't hit the edge. I'm preventing that out here, but I haven't made any kind of contract within this function, so I'm going to go ahead and do the calculation. Avoiding the edge here is an optimization. Dealing with the edge here is just necessary to make correctness in this function. So sum NW, sum NE, sum SE, sum SW. The only case which can possibly be valid. Everything I'm thinking of right now gives me just an explosion of comparisons. It's like if NW equals M and SE equals S and NE equals M and SW equals S, assuming I've even got that right, like what are all of the possible orientations? There's upper left to lower right, upper right to lower left, lower right to upper left, lower, of course I'm drawing wrong by my perspective, lower left to upper right. I just inverted left and right there. You would think that at my age I would have left and right correct, but I don't. So the possibilities are, there's 1, 2, 3, 4. Oh, there's only 4 possibilities here. This isn't so bad. Let's do it. So if northwest, upper left, is M, then southeast needs to be S. And then we'll go with northeast is M and southwest is S. I'm going to start drawing out the things that I've handled. So M, A, S, S. So here's the first case. Is that really what I did? Northeast is M, southwest is S. Okay, yes. So now I'm going to do the next case. Which, do that. I'm going to go ahead and create all of them. I think that's all of the options. It is. It is. Cool. Okay. And if we get through all of these, we're going to return false. Okay. Okay, so northwest is M, southeast is S, southwest is M, and northeast is S. Return true. Okay, now this one. Southwest is M, northeast is S, southeast is M, northwest is S. Then the last one, we'll start here and work up and to the left. So it's going to be southeast is M, northwest is S, northeast is M, southwest is S. And I've got unnecessary parentheses. That worked. Gonna silence the linter, at least this particular linting issue. Okay, let's plug this in. Solved the entire problem in half a second. I think even counting compile time. It's a lot faster this time. Oh yeah, it did compile. Okay. So 1,936. Am I correct? Nailed it. That's awesome. That was fun. That was really fun. If it had been more complicated, if there had been, like if horizontal and vertical had been options, this would have been a lot harder to solve. I want to go ahead and plug these in here. Assert EQ. Da, da, da. 1936 on the real input. I don't think that's going to still be visible. Oh, it is. There we go. And that, I think, solves the whole thing. I'm going to verify that the tests still run. Nice. Nice. There we go. So I'll go ahead and commit this. push that up. Sweet. There we go. Okay, so that's the solution for day 4. As always, it's going to be on my Git page. So git.luminescentdreams.com. You just go exploring, you find Advent of Code. You can find my other projects too if you want to see some of the complete ones and some of the less complete ones. But I'm right here in the 2024 code. There we go. And the day 4 solution is up. So cool. Gonna call it there. I don't know if I'm going to be streaming tomorrow, Thursday night. Couple of schedule interestingnesses. So I may end up solving day 5 entirely on my own and come back to stream again on Friday for day 6. Either way, gonna call it done right there. By the way, this is where I've got like the streaming software and everything, so I keep looking over here as though I'm looking at you when really I'm just looking at like my own face. So looking back at you. Day 4 is done. Thank you for watching. This is a lot of fun. I hope some of you are getting something out of this. If you have any comment or if you have any questions or any feedback, go ahead and leave a comment for me. Share the video if you think other people would enjoy it. And other than that, I'll see you in a couple of days. Good night, y'all.